Hey guys, Mrs. Stans here. Sorry I couldn't be in class today, but I just wanted to do a few problems from the lesson that you're working on today. So we're doing lesson 7B. It's the extra practice with the piecewise functions. It says it's optional, but you're doing it. And it starts on page 41. So you're going to work together in class on these, but I just wanted to do a couple of problems with you just to make sure you got off to a good start. So we're going to start with number 3. So it is a piecewise function. I could see that there are 3 pieces. Something different about this that we haven't done in our piecewise functions is that one of the pieces is an absolute value graph. So that'll be fun to do. So we'll start off with the first piece. It's linear. Its y-intercept is at 12. This you're going to have to be really careful because the 12 actually goes off the page. Here's 8, 9, 10, 11, and 12. Right? That's obviously going to be something that I erase, but in order to graph it right, I have to start here. And I'm going to go down 3. I'm going to go up 3 to the right 1, which is the same thing as going down 3 and to the left 1. And now I'm finally on my graph, which is nice. Remember, I knew to make it slant that way because positive slopes slant in that direction while negative slopes slant in that direction. So I had to make it slant this direction. It exists for all x's less than or equal to negative 3. Here's negative 3, and all x's less than or equal to that. Erase the other points. Check open circle, closed circle. It should be closed. And there's my first piece. The second piece is the parent graph, the absolute value parent graph. It doesn't shift anywhere, right, because there's zeros here, so it starts at the origin. Its steepness is 1 on each side, up 1, over 1. And its absolute value, so it makes this V-like graph, V-like shape. These I could tell I'm going to be erasing because I can't have any points one above itself. And let's see really how much I'm erasing. So it's from negative 3 to positive 3. Those are the points I'm connecting. Erase the extra points. And we have just one piece left. So, I shouldn't have erased those marks up here. I have to go up to 12 again. 8, 9, 10, 11, 12. Start at 12. Now it's a negative slope, so it's going to slant down this way. Down 3 to the right 1. What I can guess is that it's going to be like an M, the final shape. These are probably going to be erased because you can't have anything above something. I need to see all x's greater than or equal to 3, and it's those. Erase the extra, and I'm done. It does ask me for the domain of this function, so I can't put it over here. It's going to go to negative infinity because the arrow is going out. This is going to go to positive infinity because the arrow is going out. And there's no gaps in between. So it is all real numbers. Or you can write from negative infinity to positive infinity. The range arrows, so it's going down to negative infinity, but it does come right to there. 1, 2, 3. So it's from negative infinity to 3. The 3 has closed circles, so it's included. And that is your domain and range, and this is how we graph piecewise functions, and this one even included an absolute value. So there's one. We're turning the page, going to number 4. So we have to write a rule for the function shown. So I have this horizontal line here, and then I have this slanting downward and this slanting upward. So we can say, and that's an open circle and an open circle. How about we call it f of x, and we write something for the 3 pieces. Horizontal pieces I love. It's a horizontal line at 2, and it exists right there for all x's less than negative 4, not even equal to, just less than. Next, this downward slanting line, it's going down 1, right 1. It is slanting downward, so it's negative 1x plus, where it crosses the y-axis, negative 2. So I'm actually going to write it as minus 2. And it exists in in-between range. So I just got to get my cards. It exists from negative 4 to 2. The domain goes from negative 4 to 2. Open circles in both places. From negative 4 to 2. X is between negative 4 and 2. These are less than, because negative 4 is less than 2. And then this is an upward slanting piece. It's going up 1, right 1. I can't see where it's hitting the y-axis, so I have to extend until I find it. Right there. It's going to hit at negative 6. There is an arrow there, so this exists for all x's greater than 2. And there we go. Finally, I just want to remind you about your function notation. So we'll look at numbers 5, 6, and 7. So this doesn't have a graph for me to look at. You know, I usually like looking at the graph and finding, so I have to do the evaluation. So you just have to be careful about what piece you plug it into. This is telling me that x is 7. So I have to look at where it exists to decide what piece to plug it into. If I put a 7 in here, 7 is greater than 4, so it exists in this piece. It doesn't exist in this second piece. So I have to use the 3x minus 5, and in place of the x, I put the 7. It's not 18. 16. F of 4, remember we're looking where x equals 4. It doesn't equal it in the top piece, it's only greater than it. Here, it's less than or equal to. So I'm going to plug it into the second piece, into the x squared. Make sure when you substitute in your number that you put it in parentheses. So 4 squared is 16. Finally, f of negative 3, we're looking for where x equals negative 3 exists. It's not the top piece, it's the bottom piece. It's an x squared, so when I plug it in, make sure it's in parentheses, because a negative 3 in parentheses squared is different than a negative 3 not in parentheses squared. This means negative 3 times negative 3, therefore the answer is a positive 9. So with your partner, you're going to work on the rest of the lesson. So you're going to go back to page 41, finish those questions, finish 42, and then your homework is on page 43 and 44. So you can start that in class as well. And I'll see you tomorrow. Thanks. Bye.